All right, so we've got vision, and then hearing. We'll see how much we get through vision here a little bit, and then we'll leave the rest for Tuesday for us. Okay. There's a number of things that go on with vision. Vision we associate with the eyeball, but there's a lot of stuff around the outside of the eyeball, that are just as important into the functionality of what the eye does, and these are collectively referred to as the accessory structures of the eye. They include our extrinsic eye muscles, lateral rectus, superior rectus, all of those that we talked about with the cranial nerves, okay? There are 6 of those. They attach to the sclera around, the outermost layer of the eyeball. Then we have the eyebrow, helps to, keep sweat from getting in our eyes. It allows for this thing called nonverbal communication, which, is pretty important. We have what's called the conjunctiva. It's just a lining that we'll see here in a second. Eyelashes. Eyelashes you find at the lateral margin of the palpebra, which is the eyelid. They keep stuff from getting in the eye. So eyebrows have a number of root hair plexuses around them that help to initiate the blink reflex. So that helps to protect the eye. And then we have this thing called a lacrimal gland, and it produces tears that go across the outer surface of the eyeball to sustain it, to get rid of stuff that lands on the surface of it. A bunch of fantastic things. When we look at the eyelid, the fancy word is palpebra, so you probably should know that. We have a muscle that attaches to this upper eyelid that's called the levator palpebra superioris. That's what raises the eyelid. When it relaxes, it closes. We don't have levator palpebra inferioris. It just moves down when you open and close your eyelid. The eyelid itself is made up of this thing called a tarsal plate. It's just a fibrous connective tissue type of core there. That's all it is. I don't know. I can't show it, and I don't like touching my eyeball, to be honest. I think they're weird and creepy. We have the space in between. Okay, that eyelid and this eyelid right here, and that's called the palpebral fissure. Just the gap, obviously, that changes when you squint or a little bit as compared to having your eyes open, right? So that's the palpebral fissure. That's what that is. We have a probably just stay over here. We have this region right here. Ugh. And we have a region right over here. These are the commissures. These are the medial and lateral commissures. They are what connect the upper and lower eyelid, basically. Canthi is plural, so that's sometimes they're called the medial canthus and the lateral canthus, but we'll just use medial and lateral palpebral commissures. And lastly, in the field that is this eyelid right here, we have the tarsal plate, but scattered throughout the tarsal plate are tarsal glands. They are specialized sebaceous glands. Okay, they help to produce an oily secretion that spreads across the surface and prevents your eyelid from sticking to your eyeball. There's some sebaceous glands, some sweat glands as well. So they have everything that you would have on any other section of skin, to be honest. We have the outer surface of the eyeball or the inner surface of the eyelid. Let's see if they show it here. Oops. Okay. Along this. Yeah, and they do a pretty decent job of showing it. We have this part right here, which is on the back side of the eyelid, and across the outer anterior portion of the eyeball, the sclera. we have this thing called the conjunctiva. And I'm just going to keep highlighting here, right there. This all is the conjunctiva. There it is. Okay. It's just specialized. Well, you've seen that word before. Stratified columnar epithelium. Stratified, many layers of column-shaped cells. So it's there for protection, right? That's what all stratified columnar pretty much did. And there, I'm just giving you, I think I highlighted it. You know, I don't know if it's highlight worthy, but there are two parts to it. The part that actually covers the sclera, which is the white of the eye, and the part that covers the backside of the eyelid. Okay. You know, those weird people that can take their eyelid and kind of show you the backside. That's the part that would be the palpebra conjunctiva. If it becomes inflamed and irritated, there's your pink eye, or the correct anatomical name would be conjunctivitis. And as a funny side note, I never had pink eye as a kid. I had pink eye. I think I've had it 3 times since I've had kids. They're like disease carriers. They're unreal. But I mean, it's just there for protection. It allows light to enter, you know, I don't know, pretty easy, pretty basic stuff, to be honest. One of the last accessory structures we have before we jump into the eyeball, where all the fun is located at, and that is the lacrimal apparatus. The lacrimal apparatus is a number of things. The lacrimal apparatus is the gland, the caruncles, the canaliculi, and the sac. All of these things are what are collectively referred to as the lacrimal apparatus. When we talk about the lacrimal apparatus, though, when we talk about it, we always just talk about the lacrimal gland, right? And that's always lateral, okay? I hope you all know that the nose is medial, so the lacrimal gland has to be lateral. It is, okay? Superior lateral, okay? So if you damage that region of the eyeball, of the orbit, you can have some severe issues, okay? You can have some severe issues. You could interfere with the body's ability to, you know, produce and release tears, for all intents and purposes, onto the surface of the eyeball. When we look at that fluid, the tears that get produced, I mean, this is what it is. It's water, shocking, some sodium, some antibodies, IgA, a little bit, but who cares? Antibodies, and this antibacterial enzyme called lysozyme. So pretty indescript. So if you know what all the components are, you can probably figure out the function of the lacrimal fluid here. It lubricates, it nourishes, moistens the eye, because who doesn't love to say the word moist? Reduces eyelid friction, because it is water. Lysozyme in it, so it helps keep bacteria at bay. Does provide, like I said, some nourishment, oxygen as well. So there's some fun stuff it does. I'm not going to ask you how many times you blink per minute, but I just find it fascinating, so I put it in there. So you blink about 15 to 20 times per minute, and every time you blink, that squishes or squeezes, if you will, some of that fluid out of these tiny little canals up here that are extended from the lacrimal gland. And every time you blink, you help to kind of wash that tear over the surface of the eyeball, okay? And it all kind of flows over here to where these two little puncta are, these lacrimal caruncles right here. They lead to these small canals called canaliculi, and this is how the tears get off the surface of the eyeball. Enter into this nasolacrimal sac, which dumps into a nasolacrimal duct, and that dumps it into your nasal cavity. So it's why your nose runs when you bawl. Okay. Then you swallow it or spit it out, whatever. So those are all the accessory structures. They are outside the eyeball. They either move the eye, maintain the environment of the eyeball, protect the eye. They're not necessarily involved with well, I mean, they are in a roundabout way, vision, but they aid the vision process. Okay. When we dump into the eyeball, here's what it looks like, very simplistically. Okay. An eye has 3 layers or 3 coats. Tunic means coat, right? So we have 3 coats or 3 layers. And it's surrounded in a little bit of fat to help cushion and protect it as well. So, I mean, there is that, but I'm not getting into that. We have the fibrous tunic around the outside. We have, and that consists of the sclera and the cornea, as you can see. We have the middle tunic, the middle layer, that is called the vascular tunic. It consists of the iris, the colored part of the eye, the ciliary body, which helps to alter the shape of the lens. And we have the choroid, which is the actual kind of blood vessel carrier. And then we have the most inner layer of the eyeball that is usually referred to as the retina. Tunic is not involved there, just it's called retina. And this is where we have our photoreceptors. As you can kind of see here, there are a couple of huge cavities. One's really big and one's smaller. And these cavities are called the posterior cavity and the anterior cavity. The line of demarcation for these guys, and I'm pointing these out because we're going to divide these up even further, at least one of them, okay? The lens is the line of demarcation. So the big region, the big cavity in front of the lens is the anterior cavity. And it houses aqueous humor. It's clear. We'll talk about it as soon as we get through the vascular tunic. The area behind the lens, and that's a massive region right here, is filled with vitreous humor. Okay. And your eye is about, 2.5 inches in diameter. Okay. And so you can see the vast majority of that thing is going to be this posterior cavity. It says permanent because you're born with it. Right? You're born with your vitreous humor. Some old school texts refer to it as vitreous body. Just call it vitreous humor. It is dark. It helps to absorb excess light. In the anterior cavity, we have aqueous humor. It's clear. It's like a liquid. And it's clear so we can get that image to come in through the eyeball. Okay. And it circulates. You constantly produce it. All right. And if you have some kind of blockage up there, then there's your glaucoma. All right. 2 cavities, 3 layers, or tunics. So here's our outermost layer. It's basically tough connective tissue. As you can kind of see here, it's dense, irregular. So, yeah, whatever. I don't know. Sclera, it's the white of the eye. Its big claim to fame is what it does. It helps to maintain the shape of the eye. It gives the eye, the extrinsic eye muscle something to attach to. Okay. So those are its 2 kind of functions. And really that's it. I mean, it's dense, irregular connective tissue. Yes. I mean, so, I don't know. That's functions is what it does. It's probably the most important thing. The cornea is the specialized portion of the sclera. Cornea is a specialized portion of the sclera. It's specialized in that it is clear. Okay. It is clear. That allows light to enter. You can kind of see there it's, stratified squamous epithelium. It's just very specialized. It's called corneal epithelium. That's why we can replace that cornea. Epithelium doesn't have a good blood supply, if any. Gets it through diffusion. So that's why we can replace those suckers here because no blood, no reaction. Cornea allows light to enter, so it refracts the light. That's its function. Let's the light in. Okay, let's the light in. The vascular tunic has 3 parts to it. It primarily, its claim to fame is what it, is the choroid. Okay, that's the number 1. Okay, that's number 1. And it houses the capillaries that provide nourishment to the eyeball. And really, I mean, we're talking about to the retina. As you can kind of see, it does have some melanocytes in it. So it will help us to absorb excess light, just like melanin helps to darken up the skin when you expose it to UV light. It doesn't necessarily darken up here, but they are helping to absorb the excess light that does enter into the eyeball. The second big thing here is the ciliary body, and the ciliary body is the muscle and the strings that attach to the muscle. And okay, ciliary body right here includes this muscle. And the little strings that attach to it. Okay. And what does the ciliary body do? There's its function. Alters the shape of the lens, allows you to see close up or far away. There's a number of processes. They contain capillaries. Another major function of the ciliary body is what it produces. It produces aqueous humor. So we have muscles that contract and relax, change the shape of the lens. And we have that aqueous humor that we mentioned earlier floating in that anterior cavity. So that's the dude who does it. The last portion is the iris, and the iris houses another structure, I guess, which is the pupil. But the iris is what makes me look so pretty, giving me my nice blue shade of eye color. You could be brown. That's okay. We still love you. You could be green. That's okay. Still love you. Okay. But we all know that blue's better, right? I'm joking, but I'm speaking the truth. Here, we also have in the center of the iris, we have the pupil. And that's how light gets into the dang eye. Okay. There you go. Iris, pupil, pupil. Holy smokes, look at that sucker. Really big. Okay. Change the shape of the pupil by changing the diameter of the iris. Okay. And we can do that through various different muscles. They're listed right there. Right. But before I go to those muscles, remember that anterior cavity we talked about? Ugh. It is subdivided. And this is one of the most common things flippy flopped on an exam. Okay. Cavities are big. Chambers are small. Have you ever been into a judge's chambers before? I have. I'm special though. I have a fun past. All right. Chambers, when the judge asks you to come back to his chambers, very, very small compared to the courtroom. Courtroom is a cavity. It's huge compared to the judge's chambers, which is very small. In the anterior cavity, we subdivide it into chambers. The anterior chamber is from the back of the cornea to the front of the iris. From the back side of the iris to the front of the lens, that's the posterior chamber. So if I go back here, this region right here, okay, and they do a good job of showing from the front of the iris to the back of the cornea, all of this region right here is the anterior chamber of the anterior cavity. Behind the iris, in front of the lens, there is some space. That's the posterior chamber of the anterior cavity. Okay. Excuse me. So very easy to get those screwed up. And some people do on the exam. I don't know if that's a hint. Probably is. Hopefully you're paying attention. Okay. If we look at the front of the iris, oh my God, it's so pretty. But when you look at the back of the iris, you see that it's more than just a pretty face. There is a number of muscles back behind there. Okay. Muscles that go in a circular pattern, which is a sphincter muscle. Sphincter muscles are always circular in nature. And I know we haven't talked about any sphincter muscles yet, but trust me, I'm going to introduce you to the world of sphincters here in a little bit, in the next few chapters. Okay. Sphincters are circular. All right. So when these constrict, they can really make that thing small. I have these other ones that go back and forth, okay, up and down, okay. When they contract, they can pull that pupil open, okay. So dilator pupillae dilates the pupil. It's in its name, right? Dilator pupillae muscles, what does it do? It dilates the pupil. So it's pretty easy to remember, okay. I ask some free things, some easy things. To me, that seems pretty easy, okay. The sphincter pupillae muscle, sphincters constrict, okay. Sphincters constrict. Sphincters constrict and close off. In this case, they constrict the pupil, okay. Now, if we look at their concentric and their radial organization, I don't know, I guess that's interesting. I mean, but, you know, remember, sympathetic is fight or flight. And what do I want to do? I want to fight before an event. I hear something in the dark of night. And how do I bring more light in? By opening up that damn pupil so all the light that is potentially out there can get into this eyeball and I can see where I hear it rustling in the woods. Where is it at? It's right there. I know it. So this is sympathetic. When it constricts, it's parasympathetic. Okay. So now I can ask a question and dovetail it to some previous stuff. Oh, the joy of connecting stuff from previous chapters, right? This is all the pupillary light reflex. Okay, when you do your cranial nerve exam, one of those was this pupillary light reflex. Just put it in their eyeball, shine the light in their eyeball, and you can see them constrict. There's a direct pupillary reflex and there's an indirect pupillary reflex. Amazingly, both eyes will respond the same, okay? It's the body's way of kind of regulating and making sure you have a nice, image being focused on each retina that you can interpret in the back of the occipital lobe there, and it's the same. When you shine the light in one eye, if you're dividing your eyeballs up and you shine the light in the one eye, it will constrict really quick. But as you look over into the other eyeball, you'll see it. Okay, shine the light. This one really quick over here, gets a second, and then it responds. So there's an indirect and a direct pupillary reflex, but they should both constrict when you put lights in their eyes, unless you've been administered something or taken some drugs. Okay, a lot of different recreational drugs will interfere with that and give you a much more sympathetic response. Okay.